Hey everyone, and welcome to This Explainer. I'm absolutely thrilled you're here today. We're going to unpack exactly how modern software is built using Visual Studio 2019 Community. So if you've ever found yourself wondering how developers actually translate their raw ideas into functioning programs, well, you're in exactly the right place. Let's jump right into this.
Here's a quick look at our roadmap for today. 1. From binary to IDEs. 2. Inside Visual Studio Community. 3. Console versus Windows Forms. 4. Writing your first app. And finally, 5. The event-driven GUI.
All right. Section 1. From binary to IDEs.
You know, in the early days of computer science, communicating with machines was, well, it was incredibly tedious. I mean, programs were written directly in binary, using literal physical punch cards. Just imagine trying to debug a giant stack of cardboard. It's wild. Today, thankfully, we use high-level programming languages. These languages use coding statements that are actually pretty close to human language, which makes the logic far, far easier to write. But here's the catch. The computer itself still only understands binary. So these high-level languages still need to be translated behind the scenes. And that brings us to the ultimate tool for modern developers, the Integrated Development Environment, or IDE. Essentially, an IDE is software that helps programmers design, create, and test their code. Think of it as a seamless, all-in-one interface where you can write those high-level languages, track down annoying errors, and handle all that complex translation into binary without you ever having to even look at a punch card. It's a total game changer.
Moving right along to Section 2, inside Visual Studio Community.
Okay, before we just start clicking around the interface, we need to understand a core concept that makes modern programming so incredibly efficient, and that's classes. Think of classes like blueprints or templates. They hold pre-written code to support the functionality of objects. So instead of writing every single detail from scratch, like exactly how a button should look or how a window should minimize, programmers can just use these templates. It saves a massive amount of time by giving you optimized, ready-to-go code for common objects you're going to use over and over again.
So, when you fire up Visual Studio to start a brand new project, you aren't just staring at a blank, intimidating text file. Instead, you're greeted with this Create a New Project window that features a vast array of templates. You can filter this by language, like Visual Basic, and pick exactly the kind of scaffolding you need for your app. The whole thing is designed to get you coding your unique logic faster, rather than getting bogged down worrying about the initial boilerplate setup.
Initializing a new coding workspace is a highly logical step-by-step process. First, you open Visual Studio. Second, you pick your project template. And for today, we're focusing on Console or Windows Forms. And third, you configure your new project. Make sure you give it a meaningful name. Honestly, giving your projects clear, descriptive names is absolutely one of the best habits you can build right from day one.
Let's dive into Section 3, Console versus Windows Forms. All right, let's break down the fundamental differences between these two application philosophies. On the left, we have the console application. It uses a command line interface, which means it is entirely textual. It's totally uncluttered by graphics or complex user interactions. That makes it a fantastic, focused environment for working purely on raw programming logic and algorithms. Now on the right, we have the Windows Forms application. This uses a graphical user interface, or GUI. It is visually rich, featuring elements like buttons and drop-downs, and relies entirely on an event-driven approach. These are two very different ways to solve computational problems.
You can really see the contrasting user experiences here. Console interaction is completely text-based. You input data and receive your outputs on a single plain screen, and you're relying strictly on your keyboard. GUI interaction, on the other hand, well, that's what you interact with on your computer every single day. It involves visual elements, clicking buttons, selecting things from menus, and it's primarily driven by a mouse. It's a major shift from typing raw text commands to using an intuitive visual interface.
Okay, Section 4, Writing your first app. Let's look at the basic code structure designed to display the classic text Hello World. Notice how clean and nested the organization of the code is here. The actual executable commands are neatly tucked right between the start and the end of a subroutine. It's highly logical and keeps all your instructions perfectly contained.
Let's deconstruct this Hello World program piece by piece so you can see exactly what each line is commanding the computer to do. First up, Module 1 simply holds our code. It's basically the container for our logic. Next, submain is the crucial entry point. That's where the program actually begins reading the instructions. Then, console.writeLine is the specific method that tells the computer, hey, display this chosen text on the screen.
And finally, console.readKey is a very handy little trick. It pauses the execution so the console window doesn't just instantly vanish before we even get a chance to read our message. See? Every single line has a strict, deliberate purpose.
Now, you're going to hear the word execute quite a bit as you learn to program. To execute simply means the operation of a computer program. When a program is in operation, it is being executed, or running. Bringing that written code to life so you can test your logic and see the output, that is the execution phase.
Which brings us to Section 5, the event-driven GUI.
When you're building a GUI, your workspace completely changes. You're going to use a toolbox to grab visual elements, like buttons, labels, and text boxes, and literally drag and drop them right onto your application form. But just placing them there isn't enough. You then have to use a properties window to configure those elements. You can customize their size, change their background color, and most importantly, give them meaningful identifier names so your background code knows exactly how to interact with them later on.
But that brings up a really fundamental structural question for any graphical interface. How does the code actually know when to run? Think about it. In a console app, it just runs linearly, straight from top to bottom. But in a visual interface with a dozen different buttons and menus, how does the program know what to do and when to do it? Well, this introduces the fascinating and absolutely essential concept of event-driven programming.
Take a close look at the title of the subroutine in this code snippet, private sub btn show_click. This right here reveals the magic of GUIs. A physical user action, like a user moving their mouse and actually clicking that specific button on the interface, is the exact event that triggers this specific subroutine to execute. The code essentially sits there, patiently waiting for that click event to happen. It's a completely different, highly reactive way to structure a program's flow.
To wrap things up today, I want to leave you with this final provocative thought. We've just explored the raw text-based logic of the console and the reactive, event-driven visual interfaces of Windows forms. So, how does mastering both of these approaches develop your overall computational thinking? Well, understanding how to structure raw algorithmic logic step by step, while also knowing how to build user-friendly, interactive systems that respond to real-world events, that makes you an incredibly versatile and complete software creator. It's all about having the right mental model for the right job. Thanks so much for joining me on this explainer, and keep exploring.